Now, how do I copy files during the build? So with what we saw so far, if we had a real application, we could already do something. Like, let's say my real application is on a GitHub repo. I could do run git clone from the repo and etc. It would work, but it would also be extremely annoying because of the caching system. When I want to rebuild, I would have to do a docker build -- no cache, because when the build system sees git clone from a repo, it's like, oh, I already cloned that repo, so I don't need to clone it again. So each time you push some changes, you would have to do a build no cache, and that would really be a pretty horrible experience. So instead, the idea is that the Docker file is going to live in the repo right next to the other files, and then there is a special command in the Docker file to copy some files from the code repo into the container, and that command is called copy. So here we are going to have an extremely complicated example using some C code, and since I haven't written C code in a decade maybe, I had to stick to something really basic. So I'm going to make a new directory. How do I call it here? New dir. And I create hello.c. I'm going to type this, but you're welcome to copy paste if you want. By the way, I forgot to mention that in the beginning, but you can see the slide number in the top right corner, and if you want to jump to a slide, you just have to type the number of the slide. So for instance, if I want to jump to slide 100, I type 100 enter, 100 enter, yeah. And if I want to go back where I was, it was 176, so 176 enter, and then I could copy paste that code if I were lazy. Which, I mean, I'm lazy, but I'm going to force myself to type it. So int main, put s hello world, return 0, and that's it. I guess even if you have never written C in your life, you can guess what this program is going to do. Then we are going to write a Docker file. So we're going to do like from Ubuntu run apt-get update, then run apt-get install build essential. I'm going to deliberately make a mistake. I'm going to forget the -y argument here so I can illustrate something. And then I'm going to do copy hello.c /, then run make hello, and finally cmd /hello. So apt-get update so that I can get a list of up-to-date packages in my container. Apt-get install build essential. This is a Debian meta package which will pull down like the C compiler and some basic libraries, and also the make build system. Then copy hello.c /, that means take my little hello.c source code and put that at the root of the container. Run make hello, that means execute make hello. This is using something called implicit rules in make. When you do make hello, if it finds a file called hello.c, it's going to invoke the C compiler to create an executable from that file. If I had hello.cpp, it would invoke the C++ compiler. If you have both hello.c and hello.cpp, don't ask me what happens, I have no idea. But in that case, it's just like it saves me gcc-o hello whatever command. So remember, I made a mistake in that file. I forgot to put the -y flag at the end of that apt-get install here. So let's see what happens if I try to build that. Docker build -t hello dot. So I get a bunch of output, and at the end I see abort the command, return a non-zero code, and my image is not built. What happened here? Well, apt has this behavior like if you do apt-get install Figlet, Figlet has no other dependency, so it's like, okay, right, let's install that right away. However, when I do apt-get install build essential, that's a virtual package that depends on other packages, and then apt-get is asking me for confirmation. It's like, are you sure you want me to install those 57 other packages? The problem is that normally there is somebody in front of the keyboard to be like, oh yeah, I want to do that, that's fine, and press enter. In that case, there is nobody in front of the keyboard because this is a container build. So since there is nobody in front of the keyboard, when apt tries to read my feedback, it gets end of file and it assumes that something is very wrong and it aborts. So I have to tell to apt, I want this build to be non-interactive. I don't want you to ask me any question, or rather, I want you to assume that the answer to all your questions is going to be yes, do it. And that's what the -y flag is for. So I'm going to go back to my Docker file, and here I'm going to add -y. And this is not just for apt, but in a Docker file, if you have any action that requires user input, you should tweak that so that it doesn't require user input. Sometimes you can have an installer that asks a bunch of questions. Worst case scenario, you can hack around that by doing like echo answer 1, answer 2, answer 3, pipe the installer. That most often times that will do the trick. But okay, now Docker build this again. So this time it's going to ask me, hey, do you want to install those 57 extra packages? Since I use -y, it's going to assume that yes, I really want to do it. So it's downloading them, unpacking them, and setting them up. Then it's going to copy hello.c in the container. Then it's executing make hello. I have like a big scary red text here. It's red because it's on standard error output. Like it's just the build process is like that. If there is anything on std_error, it will show it in red as a kind of way to say, hey, maybe you want to look into that. It's just a warning because in C you should, like when you use a function like that, you should include the right headers before, but it still worked. It's just a warning. So I have my hello image, and you will probably be shocked to see that if I do docker run hello, it will display hello world. Okay. So if I build again, my friend the build cache is going to kick in, and the build will be almost instantaneous. Now what happens if I change the file hello.c? If we stick to what I explained before, the build system is looking at the Docker file and checking if something changed. If I change hello.c, like hello, world, I didn't change the Docker file, so normally the build cache should kick in and my code will not be rebuilt, but turns out that it is being rebuilt because the build cache is being smarter than that. When there is a command like copy, which is bringing in some files from the build context to the container, it's going to look at these files and check if they have been changed. Because if you change your code, you probably want to rebuild the container anyway. But yeah. Does it use timestamps? How does it know? That's an excellent question.
If I didn't touch on the file, how it actually doing it?
You know, that's an excellent question. Let's check it out. I'm going to touch the file and Docker build again, and it was able to see that it's apparently it's not using timestamp. So I can't remember if it's. I don't think it's keying by the entire content. It might be using a hash, but um, that's an excellent question. I'll have to look that up. But it's not just the timestamp as we could see. So okay. You can copy stuff recursively if you want. So if you have a bunch of files, you don't have to copy each of them one by one. That's why very often you will see something like copy dot slash src, which means just copy my entire Git repo in slash src and do it. If we were doing a real Hello World program, we would probably not put the source in the root directory, because now in my container I have /hello.c and /hello. That's not super nice. If you do that on an actual server, as soon as your coworkers find out, they are going to give you weird looks. Like, are you really the kind of person who installs a source file on the root of the file system? If everybody does that, how are we going to find like? So it's bad, but when you do that in a container, it's less bad. I'm not saying you should do it, but if you do that, it's less of a big deal because it's in a container and that container is running only that application. So you're not going to step on each other feet with another person because everybody has been dumping files on the root of the file system. But so if we were doing a real nice hello world, we would probably use the work dir instruction to say, hey, let's put that in a different directory, and we would probably use the GCC official image that comes with a nice C compiler, etc.